Alright, so for section 6.3, we're going to talk about vectors. Vectors is a linear algebra concept that if you go on to take linear algebra, you'll learn, you'll go more in depth on this. But for this class, we just kind of get a brief just discussion about it. Alright, so a vector is the set of all line segments directed that are equal to a given segment in the plane. And I know that definition's a little bit quirky, so let me just kind of show you what a vector is. So we've got our plane here, which is what we're only going to talk about 2 dimensions. So think of like the coordinate plane, like that we graph on. A vector is just something that has a starting point that we call the initial point and a terminal point with a direction. Okay, so that vector will go to here, but it moves in this direction from the lower point to the higher point. That's all the vector is, okay? And so the starting point is called the initial point, and then the point with the arrow is called the terminal point, and the arrow just helps us to denote the direction that the vector is heading in, okay? And there are 2 basic operations that we can do with this. And the 2 basic operations are to scale it up or down by multiplication. So we can do multiplication or addition. Okay. So we can do multiplication or addition. And addition is just simply called vector addition, but multiplication we do refer to as scalar. So we're scaling the vector up or scaling it down. All right. And one of the more important things that we can use with a vector is to find its magnitude, which is really just to say that we find the length of the vector. All right. And so how we do that, and we denote vector or magnitude by this 2 vertical bars on each side of the vector name. And something else too from a naming a vector standpoint. The textbook, like many print, will use a boldface lettering, but because if you're handwritten with this, you just use this little half arrow thing above it, and that just lets the reader know that you're discussing a vector. All right. But the vector magnitude is the square root of the difference of the x values squared plus the difference of the y values squared. Okay. So let's look at an example here. So we've got a vector that vector v that has a starting or initial point at 0, 0. It has a terminal point at 3, 2. Okay. So 3, 2. And so if I wanted to find the magnitude of this, I would just take the square root of the difference of my x's, so 3 and 0 squared, plus 2 minus 0 squared. Of course, that is 9 plus 4, which is the square root of 13. And so this vector has a length or a magnitude of 13. Okay. Another important characteristic is the slope of a vector. So you'll see it denoted slope and then have the little subscript name of the vector. And so staying along with this, it's the same as the regular slope, y2 minus y1 over x2 minus x1. So in this case, we have 2 minus 0 over 3 minus 0, which is 2 divided by 3. So that vector has a slope of 2/3, just the same way as a line would, but now we also know a distance, the magnitude, the length. Okay. And we represent vectors in what is called component form, okay, because it's not really a point in the plane. A vector is a line with direction in the plane, so we can't use our standard x, y in parentheses. But component form of a vector will look something like this. It will use the arrow and then say -4, -1. All right. And what this component form of this vector tells me is that if I start here at 0, 0, my vector ends out here at -4, -1. And so I end up with a vector that looks like this. Okay, so that's how we represent it, is in component form. All right. And so just to throw this in there, the two operations that we could do are addition. The best thing about the components of vectors and their operations is they're component-wise. So if you have u plus v, the vector u plus vector v, then you just really have u1 plus v1, and then u2 plus v2. So the two vectors that we were using, let's say u is -4, -1, and v is the one we were using on the previous slide, 3 and 2. Okay. So if I wanted to figure out what u plus v is, I just add the first components together, and then I add the second components together. And what this would leave me with is a -1, 1. So the resulting vector of those two, if I add them together, is -1, 1. All right. The other thing that we can do with vectors is the operation is scalar. And with scalar, that just means that we scale it up or down, so we multiply. So what happens is I get k times the first component of u, and then k times the second component of u. So let's say k is equal to 3. All right. So then I get 3 times the vector of u, which is 3 times -4, and then 3 times -1. And that gives me the resulting vector of -12, -3. Okay, so that is scalar. All right, so this concludes section 6.3. Again, we don't do a deep dive into vectors. We just kind of do a brief overview. We'll do a few more things within section 6.4, but as always, if you have any questions, please feel free to email me, and have a great rest of your day.